about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Let's go, let's be free with me. Be free. Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free.
Good afternoon, John here from Tutor to You HQ. Welcome to this, our first A-Level Geography live stream session of the year. Hoping you could just catch that little bit of a fanfare. Welcome. Yes, our first live stream session of the year. We're going to be here every Tuesday, 5:30 for the rest of this term. Lots and lots of important topics to cover. If you're joining us live, welcome. And I can see from my screen immediately we've got quite a few people who've joined us live. Always good to see you, and hopefully you're going to participate. I'll come back to that in a second. If you're watching this on replay though, also a very big welcome. Now, I'm joined by two of our most experienced and, dare I say it, two of our most popular presenters for geography. Welcome to Catherine and to Brendan. How are you both?
Hi, absolutely fine.
I'm hoping you're rested and recuperated after your summer holidays and are ready to get cracking again on another set of live stream sessions. If you've not watched one of these before and you may be new, if you're new to year 12, we're hoping desperately that you're going to participate in the activities and give us some of your thoughts and answers. To do so, you need to just very quickly subscribe on the YouTube channel. So just click the subscribe button. That will enable you to add in some chat, and then you'll be able to give us some of your thoughts and answers as we go along. Okay, we have got 30 minutes on the carbon cycle, feedbacks and mitigating climate change. That's a heck of a title, guys.
No pressure.
Well,
Yes, yeah.
The thing is that they're A-level students, so they're up for a challenge. I know they are.
Absolutely, you're not wrong at all. So please do participate. Please do put your answers in there. I'm sure Brendan and Catherine would love to hear some of your thoughts and responses. If you're both ready, shall we get started?
Far away. Okay, so I'm starting off with a little challenge for the students because I really want to get their brains warmed up for this session. So what we're looking at here is mean global temperatures, and we are doing an activity which is dearly loved by Tutor to You, which is higher or lower. So what we've got here is, first of all, the 1880s. So we're going back in time to the 1880s. And what I'd like the students to do in the live chat is to tell me in a moment when we reveal the first date, do they think that the temperature in the reveal date was higher or lower than in the 1880s? So let's start doing a little bit of revealing. Right, so in the 1880s, we had mean global temperatures of 13.73 degrees C. So if we reveal the next date, right, so we're now thinking about the 1940s. So what I'd like to see is people saying in the chat box, do they think the mean global temperatures were higher in the 1940s than in the 1880s, or were they lower? So let's see some people commenting for me. Type in either higher or lower. Excellent. Thank you to we've got Alex getting us off to a good start there. Thank you, Alex, for your contribution. Let's see some more. Right, okay, brilliant. Oh, a few people saying higher now. Right, so should we reveal and see, was it higher or lower? Right, okay, yes, there had been a temperature increase by the time we got to the 1940s. So a slight increase in mean global temperatures. So let's have a look at our next date. So the 1960s. So let's have a think now. 1960s, we're in the era of the miniskirts and everybody's dancing to the rock and roll music. And were the mean global temperatures higher than in the 1940s, or were they lower? So again, let's see some suggestions going into the chat box. So let's see what people think. Would the temperatures have gone up again, or would they maybe have gone down this time? So Tutor to You is thinking maybe temperatures went up. Any other thoughts? Okay, so shall we have a reveal to see? Now, this is what we got to be really careful of, you see, when we're thinking about mean global temperatures, because actually in the 1960s, there was a slight decrease in the mean global temperatures. But when we are looking at climate change, we are looking at trends over a period of time. So we did see between the 1940s and the 1960s a slight decrease in the mean global temperatures. But if we reveal our next date, right, so in 2000s, what do we think? Did we continue with this trend of being slightly lower, or did we get back up to having higher mean global temperatures again? So let's see in the chat box. Let's have a little look at what you think. Now, of course, one of the complexities as well of global temperature is we get differences in different parts of the world. So when we get changes, we've got temperatures changing at different rates in different places, and that's affected by a lot of different factors. So it's actually very complicated to calculate the mean global temperatures. And so, as I say, we're looking for trends there. So let's see what our last reveal is for this game. Okay, so yes, it had gone up higher by the 2000s, but also you can see that that is substantially higher than it was in the 1940s as well. So our trend that we're looking at is showing that we have had an increase in mean global temperatures over that period. Great stuff. Thank you to everybody that joined in there.
Many thanks, Catherine.
Right, over now to Brendan.
Thank you very much, Catherine. So we've reviewed some of those temperature changes over the years, those trends. Now we're going to look at the carbon cycle and a quick review of what it's all about. So first of all, the carbon cycle shows the flows and transfers of carbon between stores. For example, carbon moving from the atmosphere into organic matter via photosynthesis and then moving back via things like respiration or combustion, when things get burned. Secondly, we can talk about carbon being stored in different parts of the atmosphere. So we've got the lithosphere, which really means the Earth's crust, the hydrosphere, which includes oceans and lakes, the cryosphere, which includes the cold things like glaciers, biosphere includes plants and animals, and the atmosphere, of course, is the layers of gases all around us up to the edge of space. And the carbon cycle acts very much like a closed system. So the amount of carbon on the planet never changes, but the amount of carbon in a specific reservoir can change over time as carbon moves from one reservoir or store to another. Now we can look at the relationship between flows and stores. It's got to be really clear. You've got to be sure about the transfers that are occurring. If one component changes, something called feedback will occur, and we're going to look at that in a little bit more detail in a moment. And a balanced system is what's called something that's in dynamic equilibrium, which means it's going along more or less at a steady state. So we mentioned equilibrium. So how does that correspond with feedback? Well, positive feedback is not necessarily a good thing. It sounds like a good thing, but it actually isn't. And we also have negative feedback, which is possibly quite a good thing in many respects. The famous economist, Kate Raworth, you may have seen her ideas about, for example, donut economics. She suggests changing the names, if it helps you, from positive feedback to reinforcing loops and negative feedback to balancing loops. And this may help to avoid confusing the fact that positive we normally associate with being good. In this case, it's not really very good on the whole. One analogy that I sometimes use with my students is to remember the path of equilibrium. You could correspond it to your recent GCSE results, perhaps. Think of all the things on the way that were distractions, like social media, television, whatever. They could be positive feedback, taking you away from the path of equilibrium. But there would have been various carrots and sticks bringing you back. Things like your own interest, your motivation, reminders, God forbid, detentions, things like that, negative feedback things that bring you back to, if you like, the straight and narrow. So it's really important concept, this notion of how feedback works, particularly in the carbon cycle. Over to you, Catherine.
Thank you ever so much. So this systems approach is something which really underpins a lot of A-level geography, not just looking at the carbon cycle, but also looking at the water cycle. In human geography, the systems approach is used looking at things like trade arrangements. So the systems approach is really important. And what we're looking at today is the systems approach in relation to the carbon cycle. And we're thinking about how understanding the way the system works and understanding about positive and negative feedback can maybe help us in coping with climate change. So that's how this all links back to that starter activity, thinking about the temperature changing, because the carbon cycle is absolutely a vital thing to understand what's happening with climate change. So we have another little activity for you here. And what we have got here is either a positive feedback loop or a negative feedback loop. And what I would like you to do is look at these sentences and have a little think about what order they would need to go in. And then there's a clue because one of them says forming a positive feedback loop. So you can see at this time, we are talking about a positive feedback loop. So what I need you to write into the chat bar is the numbers. So think about which one you are going to start with. Okay, so you could start with maybe number 5. Global warming means that ice is melting in the Arctic. But then what I want you to do is think about after number 5, which number is going to come next. So write down all the 5 numbers in the correct order to form the perfect paragraph. So start off with 5 and then see if you can figure out what order we could put those in to make that perfect paragraph. Right, we've got some very zoomy people going straight away onto that. Let's see if we got some other answers as well. I'd love to see a few people having a go. And one of the reasons for having a go at doing this perfect paragraph activity is that it's a little game for us to play this evening, but also when you are answering in your exam, if you've got questions that you need to write your extended answers, which is the main way you're assessed at A-level, you need to be thinking about constructing these perfect paragraphs. So let's see, we've got Samuel has come up with a suggestion, and thank you, Alice, as well. And Alex is, I think, saying that they agree. So we've got the little sign there. So shall we have the reveal and see what order I thought made a perfect paragraph? So see if it agrees with you. So we're starting off with global warming means that ice is melting in the Arctic. When the ice on the frozen lakes melts, methane is released from the lake. And of course, methane is a powerful greenhouse gas. So greater concentrations of greenhouse gases mean that global warming accelerates. This increases the rate at which ice melts in the Arctic, forming a positive feedback loop. So hopefully you can see here how we've got the system spiraling away from equilibrium. And that's why I drew the picture of the spiral on the slide earlier, because the system is moving further and further away from equilibrium. And what is scary in this case is that the more ice is melting, the warmer the temperatures are getting. This is having consequences right around the world. So this is a very good reason to be aware of these ideas. Brilliant. Okay, so on to the next one. So Brendan, I think you're going to give the big reveal a go.
I'm going to do my best, Catherine. Thank you very much. So the
Go
big
for it.
reveal here, you have to try and figure out what is hidden behind the question mark. So there's a question mark there. You're going to get 5 clues about what that thing is. So let's look at those clues. The simplest hydrocarbon. It accounts for 20% of the heating effects by all of the greenhouse gases combined. Its concentration in the atmosphere has risen by about 150% since 1750. Flammable and used as fuel. You can make your guesses whenever you like in the chat. And finally, it's released from rice farms, landfill sites, and when cows burp. What is hidden behind the question mark? 1 or 2 people are getting this already. Well done. Let's reveal the correct answer. Methane. Well done if you got that right. Let's have a look at the next big reveal. This one, this question mark, is colourless and non-flammable. It's the largest contributor to climate change as it is so common. By the way, it's in the news today. Concentration in the atmosphere has risen by about 40% since 1750. Released from volcanoes when fossil fuels are burned. And it's made of 1 carbon atom and 2 oxygen atoms. That's a fairly massive clue at the end. So 1 or 2 people getting that, well done. It's carbon dioxide. And the final big reveal, fast paced with these, it's removed from the atmosphere when absorbed by bacteria or destroyed by UV reactions. 60% of emissions are natural, 40% are from human activities for this question mark. It lasts quite a long time in the atmosphere, about 114 years. Its impact on warming of the atmosphere is 298 times the impact of carbon dioxide. And it's released also when certain fertilizers are used on farmland. Has anybody got that one yet? It is nitrous oxide. Well done if that's what you got. Okay, Catherine, back to you. Chains of analysis.
Right. Okay. So you might have noticed that last activity, the big reveal there, that was looking at the different greenhouse gases. And I just think, again, when we're looking at A level, we're really taking a step up from GCSE and need to be aware of the fact that carbon dioxide is often the greenhouse gas that is talked about, but methane is also very important. And then we've got the nitrous oxide there being so powerful. So we need to consider these different elements. How long is the gas in the atmosphere? How powerful is its warming effect? That is why I get really excited about A-level geography, because we're looking at all this detail, this rich detail, and really getting into these different issues. So let's have another go now at a chain of analysis. This time we are going to be looking at some different sentences. We are now looking here at negative feedback. So we looked at positive feedback, the idea of spinning away from equilibrium, but negative feedback brings the system back into equilibrium. So have a little look at these sentences and see if you can arrange them into the order that is going to give us that perfect paragraph. So you're typing the numbers in. I'm not going to tell you which one to start with this time, but have a go at popping those numbers in, think what order you want to put them in, and see if we can make a perfect paragraph explaining a negative feedback loop in the carbon cycle. This is a really nice one as well for those of you that do also biology A level, because there's quite a lot of overlaps between those two A levels. So those of you that are biologists are probably going to feel pretty confident in this one, because we're talking about things like photosynthesis. All right, so let's see what ideas we've got coming through. Lots of hard thinking going on, I think. Right, okay, so shall we have a little look at the order and see what we've got here? So yeah, so I didn't give you the number one was first, because that's, was already right at the top. But we're looking here at greenhouse gases increasing in the atmosphere, such as carbon dioxide, but plants take in carbon dioxide as part of photosynthesis. So that means that photosynthesis is enabling the plants to convert the carbon dioxide into glucose, and those plants will grow. They would get larger, they would grow more leaves. So when there's more carbon dioxide in the atmosphere, the plants are going to grow more rapidly. And that means that we've got increased transfers of carbon from the atmosphere into the biosphere, rebalancing the system through this negative feedback. Now, this is something which people can use. And what we're going to go on to do now is have a little bit of a think about how we can use some of these ideas to tackle climate change. So well done to those of you that had a go at, so I can see some answers came up there for that perfect paragraph. Great stuff. Okay, so the systems approach, it can be potentially useful in helping us tackle climate change, because we need to mitigate climate change. We need to try and reduce the concentration of greenhouse gases in the atmosphere. Now, if we can understand the positive feedback, we can start seeing where the system is being knocked out of dynamic equilibrium and is starting to spiral out of control. So we could then, if we have got the will, make changes to reduce the levels of emission. So we could look at not letting as many gases get into the atmosphere. Also, if we have an understanding of negative feedback, then we can, again, if we have the will, we can come up with new strategies which will mean that gases are being transferred from the atmosphere into the biosphere or into the lithosphere. And the example we looked at in that perfect paragraph was a great one for thinking about transferring gases from the atmosphere into the biosphere, because if we can plant more trees, then we can naturally get that carbon being stored into the biosphere. We call that a carbon sink when more carbon's being taken in than is being emitted. And we can also talk about the concept of carbon sequestration as well. So let's have a look at some thinking about this, some different strategies. Okay, so there's been lots on the news at the moment. Brendan alluded to it earlier, the idea of having different energy sources and how we've got concerns with things at the moment about energy, but also it's interesting at the moment having a shortage of carbon dioxide for use in industry. And I think that's another thing that's very exciting about understanding the different systems we've got in place here, because carbon dioxide in the atmosphere is a problem, but if we can get it through industrial processes, we can use it to make our drinks fizzy. So you've got a lot of different things here to consider in geography. And when people have been talking about the energy shortages that we are worried about at the moment, one of the potential solutions is renewable energy. So you can see a picture there that I took on my recent holiday to Northern Ireland of wind turbines. Lots and lots of wind turbines in Northern Ireland. It gets quite a lot of winds blowing in, and so energy can be generated. And by understanding the positive feedback loop that when we burn fossil fuels, we release carbon dioxide, and that then causes the greenhouse gases to increase, because we can understand that, we can say, hang on a minute, let's not burn so many fossil fuels. Let's use more renewable energy instead. And we can think about renewable sources such as wind power. However, one of the things that's been coming up with the current energy potential crisis is it hasn't been as windy as usual. And so we might need to, for renewable energy, think about different ways to use renewable energy, different sources, so that we've got a combination of approaches. Another little picture from my Ireland holiday is the picture of the forest there. And as we looked at in that perfect paragraph, planting trees is a way to remove carbon from the atmosphere, moving it into the biosphere, and the trees then using that carbon in their growth, converting it into glucose and growing. So that is a natural form of carbon sequestration. And then you've got a third picture from my Ireland holiday, because I just wanted to show off to you. And that is a picture of, in the foreground there, a peat bog. And peat is amazing stuff. And I recommend reading up on it because it's, I think, fascinating. And in peat, you've actually got a lot of carbon being stored. Huge amounts of carbon are being stored in peat bogs, such as the one in the picture. The problem is that some of these peat bogs have been dug up because people want to have peat for their gardens. Some of the peat has been burnt. Some of it is destroyed in things like wildfires. It's also getting damaged because in places it's drying out. And then the peat is more likely to catch fire in things like wildfires. So if we can conserve peatlands, that's actually going to have a massive impact. And we can do that on a more local scale in places like Northern Ireland, but also we can think about that globally. Conserving peat is massively important and sometimes overlooked. So handing back over to Brendan now for some true and false questions.
Thanks, Catherine. A wonderful review of mitigation strategies there, and great to see the Emerald Isle in your photos looking very emerald. Right, true or false? First of all, these statements, all you have to type is T or F. That's as simple as that. So the first statement, the carbon cycle is a closed system. There is input of energy and matter. Is that true or false? Let's see what your responses are. One or two people are getting it right. Let's see what the reveal on this one is. It's actually a false statement. The first part of it's correct, but the second part's wrong, because a closed system doesn't have inputs of energy and matter from outside of the system. Let's look at the next one. When a system is in balance, it is said to have dynamic equilibrium. Is that true or false? Have a think. Jot your answer in the chat. I think Alex has got it right there, and the reveal on that one is that this statement is true. It's correct to say when a system is in balance, it has dynamic equilibrium. And the next statement, methane is a more powerful greenhouse gas than carbon dioxide, but its impact doesn't last as long. Is that true or false? Let's see what people's responses are. Go for it. Is it true or false? And the reveal on that one is that it is correct to say this. Okay, next one. Positive feedback is a good thing. True or false? We mentioned it earlier on. Any thoughts on that one? Some people are saying true. Some people are saying false. Let's see what the correct answer is. It's not particularly a good thing because it can cause the system to spiral out of equilibrium. And that's particularly acute when it comes to the atmosphere. And the next one. Planting more trees is a way of naturally sequestering carbon. By the way, sequestering is a really important word at A-level for this particular topic. So planting more trees is a way of naturally sequestering carbon, causing negative feedback in the carbon cycle. Is that true or false? Let's see what guesses we've got on that one. Oh, well, not guesses, but answers. Confident answers, perhaps. Let's see where we are with that one. That one is correct. It's true to say that. Thank you very much. And back to Catherine.
Wonderful. So we set out at the start of this session to think about this big question, thinking about, do we need to understand the carbon cycle, the carbon system, to be able to tackle climate change? Now, understanding the carbon cycle as a dynamic system is definitely going to help us when it comes to designing new and effective mitigation strategies. If we understand the system and we're understanding the transfers between the different stores, then we can think about using negative feedback and reducing positive feedback to enable mitigation to work. However, not everybody in society is going to need to understand the problem of climate change in these terms to act to address it. So we need the experts in society who have that understanding of the systems approach. But if the experts are able to communicate to people how they need to change, then they could make changes without understanding the full system. But that's where we get to the however at the bottom. People are more likely to follow advice if they understand the reasons behind it. So if you're thinking about, do we need to have this systems approach and an understanding of the carbon cycle in this way to tackle climate change? Some people definitely do. But I think a really important thing that a lot of people talk about in geography and in science is the ability to communicate and help people to understand the changes that they're making in their life, which might be inconvenient. People might think, I don't want to do that. But if they can understand the reasons for making these changes, then we can effectively mitigate against climate change. I was told we were going to take the siren off that. It always makes me jump. So when you're looking at the systems of the carbon cycle and also the water cycle, which I'm going to be thinking about next week, it's really useful to have a case study to be able to back up your points. So in my school, we look at the Amazon rainforest, and we look at both the carbon cycle and the water cycle and how they operate in the Amazon rainforest. And then we also link this to the idea of climate change mitigation, the idea of the rainforest being a carbon sink, and we explore different issues related to that. Okay, so what could this look like in the exam? Because at the end of the day, it's wonderful understanding all this geography, really important, but we also want you to be able to get amazing marks in the exam. So we've got a question here. Only by understanding the carbon cycle as a system can we hope to mitigate against climate change. To what extent do you agree with this statement? So that's a 20-mark question, the sort of thing you'll come across particularly for AQA. Now, when you see these questions, they happen quite a lot, this idea of having a statement and saying to what extent. So if we just look at the next slide, I've highlighted that to what extent. To what extent is all about how much you agree with the statement. And it is a good idea, in fact, an essential idea, to look at both ways, or there may be a multifaceted approach to look at the statement, but then to say what you think about it. So you might say that in some ways it's important to have an understanding of the carbon cycle as a system and develop those points, and then say, however, and look at the point that I was just making about maybe people don't have to have a full understanding to be able to make changes. But then you need to come down on to what extent. You need to make it clear whether you strongly agree or somewhat agree or don't agree, or, you need to make some sort of conclusion to come at the end that really pulls your answer together. So if we pop onto the next slide, the other thing to think about really with this question is we've got two different aspects of the specification that are being looked at here. And this happens a lot in extended questions. So it's only by understanding the carbon cycle as a system. So to be able to do well in this question, you need to know about the carbon cycle as a system. And then it says, can we hope to mitigate against climate change? So in your answer, you need to be showing your understanding of carbon cycle as a system and your understanding of the mitigation of climate change. You need to be able to connect those two things together as well. So A-level geography is a challenging A-level, and you need to expect on these 20-mark questions that you are going to be asked to make links between different aspects of the specification and to answer evaluative questions, such as this one asking to what extent. So popping onto this next slide here, thinking about some exam gold, if we're looking at the AQA A-level specification, there are some concepts that AQA are particularly keen for you to bring into your answers, particularly the 20-mark answers. And these are listed in the specification, but they're a little bit hidden away. So just be really aware of these. We've got causality, systems, equilibrium, feedback, inequality, representation, identity, globalization, interdependence, mitigation and adaptation, go together, sustainability, risk, resilience, and thresholds. Now, what you might like to do after this session is have a think about what we've looked at today about the carbon cycle and climate change mitigation, and think about how we can link these areas to these concepts. You might need to spend a moment, first of all, making sure you understand what those different concepts are, but then have a little think. A lot of those concepts can be brought into thinking about the carbon cycle and climate change mitigation. So just to finish off, if you are interested in finding out more about water and carbon cycles topic, then you can have a little look on the Tutor2U website, and you will find that there are revision study notes about water and carbon cycles. There's also a carbon cycle revision blast from earlier in the year when we were doing some of these sessions. And I hope that you might join us next week when myself and Brendan are going to be looking at sort of the other half of this, looking at some different aspects of the water cycle.
Wow. Thanks. What a superb session. Thanks to both of you there. I was only thinking earlier on today, how can we have a shortage of carbon dioxide when there's so much of it up there in the atmosphere? It's fascinating stuff. We've still got to get hold of it there, haven't we?
Concentrations in the atmosphere are actually really tiny.
Okay.
And so if you're taking it out of the atmosphere, you have to take in a huge amount of air to be able to extract the carbon dioxide.
Okay.
So what tends to happen is that fertilizer plants make carbon dioxide as a byproduct, and so therefore they then sell it on, and that's where it's gone horribly wrong at the moment.
Okay, I see. Well, at least you had a good time in Ireland. Catherine. Those pictures looked absolutely superb. I've met Kate Rayworth as well. What a superb speaker. If anybody ever gets the opportunity to listen to what she's got to say about things, absolutely superb. Listen, thanks ever so much to Catherine and Brendan and all the team who've put today's session together. A big thank you to anybody who took part in the chat as we were going through there. I think there's a big shout out. What have I got down? It's Samuel and Alex who are answering quite a few of the questions and answering very quickly and very well. So brilliant. If you're watching this on replay, I hope you've done equally well with some of your answers, even if you haven't had the opportunity to go into the chat window. If you've enjoyed today's session, don't forget to give us a little thumbs up. That enables YouTube to know that this is the kind of content which is superb for A-level geography students. And boy, is it the right thing for our A-level students in geography around the country. Wonderful stuff. So thanks to everybody for participating and taking part, and we'll see you next time. Goodbye, everybody.
All the best. Thanks very much.
Bye.
Bye.